So in this video, we're going to look at predicting reaction mechanisms from the rate determining step, which comes up in chapter 18.4. There's a couple of different ways they can ask questions on this. And the first thing I'm going to do is look at when they give you the mechanism. So they gave you the step-by-step breakdown of how the chemical reaction occurs, and they just ask you to write the overall equations. This is the kind of the easiest type of question that comes from this topic. So if they've given you the steps and they ask you for the overall equation, all you have to do is add everything on the reactant side and then add everything on the product side. So on the reactant side, I can see I've got H2 in step 1 and H2 in step 2. So overall, I've got 2 molecules of H2, and I'm putting a big 2 in front of the H2 to show there are 2 molecules. I've also got 2 molecules of NO from step 1, and then in step 2, I've got 1 molecule of N2O. So I'm just combining those 2 steps together to write the overall equation. On the product side, I can see I make 2 molecules of H2O, 1 in step 1 and 1 in step 2. So I've got 2 molecules of H2O on the product side. I've also got 1 molecule of N2O, and I've got 1 molecule of N2. When I've written that out, I need to see if anything is the same on the reactants and the products side. So I can see here I've got 1 molecule of N2O on the reactant side and 1 molecule of N2O on the product side. That means I can cross those 2 out, and what I'm left with is my full overall equation. If we look at another example, same idea. This time the reaction has 3 steps. So it's one reaction, but it occurs in 3 separate steps. And they'll give you the 3 different steps, and they'll ask you to write the overall equation. So again, I just look at what I've got on the reactant side and add them up. So I've got 2 NOs here in step 1. I don't have any other NOs in the later steps. So in total, I've just got 2 NOs. I've got H2 in step 2 and in step 3. So overall, I've got 2 molecules of H2 on the reactant side. I've got 1 molecule of N2O2. And I've also got 1 molecule of N2O. So they're all of my reactants. On the right-hand side here, I've got 1 molecule of N2O2. I don't have any others, so I'm just going to be writing down 1 molecule of N2O2. I've got 1 molecule of N2O. Again, I don't have any others, so I'm going to write down N2O. I've got 2 molecules of H2 in total on the product side, so I'm going to write plus 2 H2O. And then I've just got 1 molecule of N2. Again, I now need to look and see if anything is the same on the left as it is on the right. So I've got 2 molecules of NO. I don't have any NO on the product side. I've got 2 molecules of H2. I don't have H2 on the product side. I've got 1 molecule here of N2O2. And I've got exactly the same on the product side. So that can be cancelled. Likewise, I've got 1 molecule of N2O here on the left and 1 molecule of N2O on the right. So again, they can be cancelled. In order to cancel, you need to have exactly the same species on the left and the right, and you need to have the same number of molecules. And what I'm left with is going to be my overall equation. The other way that they can ask this question is just slightly different. They give you the overall equation. They give you step 1 of the reaction, step 2 of the reaction, and they could ask you to fill in the third. So this is your overall equation, and they want to know how this reaction takes place. They've given you step 1, they've given you step 2, they want you to fill in step 3. And to do this, you need to use your overall equation and see what is missing. So in my overall equation, I see that I need 2 molecules of H2 on the reactant side. Looking at step 1 and step 2, only 1 molecule of H2 has been accounted for. That means in step 3, I must have a molecule of H2. So those 2 together will give me the 2H2 in my overall equation. I also need 2 molecules of NO on the left, but I can see that both of those molecules are already accounted for in step 1, so I don't need to add any into my step 3. And I'm going to draw myself an arrow and do the same for the product side. I need 1 molecule of N2. So far on my products in step 1 and in step 2, I do not have that N2. So that N2 must be made in step 3. I need 2 molecules of H2O to be made in total. So far from step 1 and step 2, I've only got one molecule of H2O. So the other molecule of H2O must be made in step 3. Now I've accounted for everything in my overall equation, but the other thing I need to do is to make sure that anything that's not in this equation has been cancelled out. So here I can see I've got an N2O2 as a product in step 1. Now N2O2 is not in my overall equation, so I need to be able to cancel this out with something on the reactant side. And if I look here in step 2, I have exactly the same species and I'll be able to cancel them out in my overall equation, which is what I want because it's not in my overall equation. The other thing I have here is N2O. Now N2O, as you can see, is not in your overall equation, which means I need to be able to cancel it out. At the moment, if I look at my 3 steps, I've got N2O on the product side, but I don't have it on the reactant side. So I've got nothing to cancel this out with. That means I must need to have N2O here on the reactant side in step 3. Now, if you do exactly the same thing as what we've done before, if you add all of these things together, you'll see you've got 2 molecules of H2. You'll see you've got your 2 molecules of NO. You'll see your N2O2 cancels out with the N2O2 here. The N2O here cancels out with this N2O, which means on the product side, you're left with 2 molecules of H2O and 1 molecule of N2. So I've now got exactly the same overall equation, so I know my step 3 must be right. I'm going to do the same thing again with the first reaction that we looked at. So there's my overall equation. I've written out step 1, I haven't written step 2. So I'm just going to highlight my overall equation. And I'm going to see what's missing from the overall equation that I need to put into step 2. So in my overall equation, I've got 2 molecules of H2. Only one of those molecules has been accounted for so far, which means step 2 must have another molecule of H2. I also have 2NO, but that 2NO has already been accounted for in step 1. I don't need to put it into step 2. On the product side, I need 2 molecules of H2O in total. From step 1, I've only got 1 molecule, which means I need 1 and a product in step 2. I also need to have N2, and you can see from step 1 that you don't have N2, so I must have N2 as a product from step 2. I also have something else here. I've got N2O on my product side in step 1. You'll see that N2O is not in your overall equation, and that means I need to be able to cancel the N2O out. At the moment on the reactant side, I don't have any N2O, so I must have N2O on the reactant side in step 2. Now I can cancel that N2O from the reactants with this N2O from the products, and what I'm left with, I've got 2 molecules of H2. I've got 2 molecules here of NO. I've got 2 molecules of H2O, and I've got 1 molecule of N2. And now my overall equation matches the overall equation I've been given, so I know I filled in my step 2 correctly. All right, the other way that they ask these questions is they give you the overall equation, so this here would be the overall, and they give you the rate equation, and they ask you to use that to suggest your own mechanism, to suggest your own step 1 and step 2. And this is harder, okay, so we're going to go through this now. In your rate equation, you only have the reactants involved in the rate determining step. So you know that the H2 and the NO are involved in the rate determining step. The other thing to look at here is the orders, because the order tells you the number of those molecules that are involved in the rate determining step. So if I let step 1 be the rate determining step, and you can do that, you can just assume that the first step is the rate determining step. In my first step, I'm going to put in H2, because that's part of my rate equation, so I know it's involved. And I'm going to put in 2 molecules of NO. So the order is important here. H2 is first order, so there's only 1 molecule of H2 in the rate determining step, but NO is second order, so there are 2 molecules of NO in my rate determining step. If I compare this back to my overall equation, okay, I can see that the 2 molecules of NO have already been accounted for in step 1. but only one molecule of H2 has been accounted for in step 1, which means the other molecule of H2 from my overall equation must be part of step 2. So using my rate equation, I'm able to write down the reactants for step 1 and for step 2. Now I need to do the products, and this is tricky, okay? But luckily there is more than one acceptable answer. So if I look here, I've got 2 hydrogen atoms, I've got 2 nitrogens, and I've got 2 oxygens. I'm trying to make 2 molecules of H2O and 1 molecule of N2. I can't make both of these products from step 1 because I don't have enough hydrogen. I need 4 atoms of hydrogen in total, and at the moment I've only got 2. But I do have enough hydrogen to make 1 molecule of water. So what I could do is I could take those 2 hydrogen atoms and I can combine them with one of the oxygen atoms from the NO. So I can make myself some H2O. If I do that, if I give one of the oxygen atoms to H2, well then what am I left with? I've got 2 nitrogens and I've got 1 oxygen left over. So maybe I'm going to make N2O. That would be 2 nitrogens with 1 oxygen left over. The other option, I'm going to write this out over here because there is more than one acceptable answer. If I do the same thing again, so I've got my H2 and my 2NO and my H2. The other option here, so I could give H2 one of the oxygen atoms, as I did before, to form H2O. Remember, I'm trying to form H2O. That's one of my products in my overall equation. So it makes sense to give hydrogen one of the oxygens. And then that would leave me with 2 nitrogens, but maybe I form N2. That's the other product in my overall equation. So maybe those 2 nitrogen atoms form N2. And then I'm left with just 1 oxygen. Remember, I've got 2 oxygens in total. I've given 1 oxygen to hydrogen to form water, and that leaves me with 1 oxygen left over. So it's just oxygen by itself as an atom, which would be incredibly unstable, but you can have unstable products as your intermediate. They're not the product in the overall reaction. So that would be another potential option here. If I go back, I'll just cover this bottom example now. If I go back and let's just focus on the first. So let's just say you've written this as your step 1. You now need to finish it off and write your step 2. So if I'm looking at my products, all right, I can see that so far I've only accounted for 1 molecule of H2O. I need 2. So I have to have another molecule of H2O being made in my second step. Also, I haven't made N2 yet. And if I haven't made it in step 1, I must be making it in step 2. So now I've got the 2 molecules of H2O on the left, and I've got on the right hand side, and I've got the 1 molecule of N2 that I need. But I've also got something else. I've got N2O, which I do not want in my overall equation. If I want to get rid of it from the product side, then I need it on the reactant side. So if I just put N2O over here, now what I've got is I can cancel my N2O with my N2O. I've got 2 molecules of H2, which matches. I've got 2 molecules of NO, which matches, 2 molecules of H2O, which matches, and I've got my 1 molecule of N2. So that will be an acceptable answer. If we look at our other possibility, so in step 1, we had a slightly different set of products for step 1, okay? But we're going to use the same process, all right? If I look at what I've got as my products for step 1, I've only got 1 molecule of H2O accounted for. That means I need another molecule of H2O down here. I need 1 molecule of N2, I've already made it, okay? But I have an extra product here, O, that I don't need. So I'm going to need to get rid of this oxygen by putting it on the reactant side. So if I write over here, O, then I've got H2 plus O giving me H2O, which makes sense. I can cancel the oxygens on both sides because they're exactly the same. And now I've got my 2 molecules of H2. I've got my 2 molecules of NO, which matches. I've got my 2 molecules of H2O. And I've got my 1 molecule of N2. Okay. The other thing to make sure that you're doing it right is to make sure your equations are balanced. So here I've got 2 hydrogens on each side, I've got 2 nitrogens, and I've got 2 oxygens. So that's balanced here. 2 hydrogens, 1 oxygen, all balanced. Same above, I've got 2 hydrogens, I've got 2 nitrogens, and I've got 2 oxygens on the left, 2 oxygens on the right. 2 hydrogens, 2 hydrogens, 2 nitrogens, 2 nitrogens, 1 oxygen. So make sure that those steps are balanced. All right, let's look at another example of the same thing. So I've given you the overall equation, given you the rate equation, and the question said suggest a two-step mechanism. And again, there's more than one right way to do this. But if I use my rate equation, I can see that one molecule of O3, because it's first order, and one molecule of NO2, again because it's first order, are involved in the rate determining step. So I'm going to let step 1 be that rate determining step. I'm going to react O3, one molecule, with NO2, one molecule. If I look at my overall equation, I've used my O3 already, but I've only used one molecule of NO2 and I've actually got 2. That means in step 2, I must also have one molecule of my NO2. Now for the product side. And again, there's more than one right way to do this. All right, I've got O3 and I've got NO2 and I'm trying to make these two products. So using what I've got, what can I feasibly make? Well, I can't make N2O5 because I've only got one nitrogen. So that's not an option. I could make some O2. Okay, if I look at all of the oxygen that I have, I've got 1, 2, 3, 4, 5 oxygens. Okay, so I could actually make 2 molecules of O2. That would only account for 4 oxygens, and I've actually got 5. So I could make 2 molecules of O2 if I wanted to. And if I did that, I would be left with 1 nitrogen, and I would be left with 1 oxygen. Okay, so that's 3 and 2 is 5, so that's 5 oxygens, and I've got 1 nitrogen on each side. Okay, so that's one possibility. Another possibility, if we do step 1 again, if I write it out the same way as before. Another possibility is that I make something else. So as I said, I can't make the N2O5 straight off the bat, okay? But looking at my equation, I can see that I don't want to make 2 molecules of O2. I only want to make 1, okay? So let's just say I'm only going to make 1 molecule of O2. What am I left with then? Well, if I'm only making 1 molecule of O2, I'm using 2 oxygens, and I'm left with 1 nitrogen, and then I'm left with an O3. So maybe I make NO3 as my other product. Okay, again, as long as it's balanced and it's reasonable, then it is going to be acceptable. And both of these were acceptable answers on the mark scheme. This is an exam question. Both of these were acceptable answers. Okay, so if we go back and we look at our first one, if that was our step 1, then what's our step 2 going to be? So if I look at my products, okay, I can see that I haven't made the N2O5 yet in step 1, which means I have to make that N2O5 in step 2. I need to make 1 molecule of O2. At the moment, I've actually made 2 molecules of O2. And that means one of those molecules of O2 is going to have to cancel with something on the left-hand side. That means I need an O2 on the left-hand side so I can cancel one of these out. I've also made NO, and I don't want to make NO. It's not one of my products here, which again means I'm going to need to put an NO on the left-hand side so that it cancels out. So let's look what I've written now and make sure it's balanced. So I've got 2 nitrogens here, and I've got 2 nitrogens in my products. I've got 2, 4, 5 oxygens, and I've got 5 oxygens in my product. So it is a balanced equation. Does it match my overall? Well, I've got an O3 on the left, which is what I want. I've now got 2 molecules of NO2 on the left, which is what I want. The O2 will cancel with one of the O2s on the right-hand side. The NO will cancel with the NO on the right-hand side. So on my product side now, I've got 1 molecule of O2, which is what I want, and the N2O5, which again is what I want. If we looked at our other example and did the step 2, okay, so here I've made O2 and I've made NO3. So I've made the O2 that I wanted to make. I don't need to make any more, but I haven't made the N2O5. So I'm going to have to make that N2O5 now. I've also got an extra product here. I've got NO3. I don't want NO3. That means I'm going to need to put a molecule of NO3 on the left so that they'll cancel. So let's make sure my equation is balanced. I've got 2 nitrogens on the left. I've got 2 nitrogens on the right. I've got 2 and 3 is 5 oxygens and 5 oxygens. So I've written a balanced equation. It doesn't match my overall. Well, I've got 1 molecule of O3, which is correct. I need 2 molecules of NO2, and I've got them. I've got a molecule of NO3 that I don't want, but I can cancel that out with the NO3 on the right. On my product side, then, I'm left with an O2 and an N2O5, which is what I want. Right, so here I've got another example. I would suggest pausing the video here and trying to do this one yourself. I've given you the overall equation, I've given you the rate equation, and you need to do 2 steps for how this reaction actually happens. So press pause, try and do it for yourself, and then press play when you've had a go, and come back and check the answer. So again, the first thing I'm going to do is start with my rate equation. I can see that I've got N2O in my rate equation, but because it's first order, I've only got one molecule of N2O in my rate equation. So I've got N2O here. That N2O must then decompose to give me my products. If I look at my step 1, I've got one molecule of N2O, but in my overall equation, I've got 2 molecules of N2O. That means in step 2, I must have another molecule of N2O. If N2O breaks down, my possible products would be N2 and then just oxygen by itself. Okay, if I just split that molecule up, I can get N2 and I can get oxygen. All right. If we look here at your overall equation, you do want to make one molecule of N2. But you also want to make a molecule of O2. You don't want to make just O by itself. So at the moment, I've got one molecule of N2 in step 1, but in step 2, I would need to make another molecule of N2 to give me the 2 molecules overall. I also need to make a molecule of O2. I haven't made that yet, I've just made O. So I would need to make a molecule of O2 as my product. You'll see here on the product side that you've got an atom of oxygen. You need to get rid of that, you don't want that. So I'm going to react my N2O with a molecule of oxygen. By putting oxygen on the left-hand side, I'm going to be able to cancel. So let's make sure everything's balanced. I've got 2 nitrogens and 1 oxygen, so that's fine. Here I've got 2 nitrogens and I've got 1 and 2 oxygens and 2 oxygens. My oxygens will cancel on either side. That gives me 2 molecules of N2O on the left, which matches my overall equation, 2 molecules of N2 on the right, which matches my overall equation, and 1 molecule of O2, which again matches my overall equation.